Okay, so let's continue our discussion of free electrons with a wave function psi x equals to a times exponential of I kx. So if you want to find the probability of finding the electrons between 0 and L of a moving free electrons, so it's not confined in any molecule, just free electrons in vacuum and space. So with a particular k value, remember k is a wave vector 2 pi over lambda. So let's say it's moving at a certain lambda. You want to know it's moving at a certain lambda. You want to know the probability of finding electron between 0 and L. Okay, and to find the probability is integration of a product of the wave function times the wave function conjugate in dx. Right. So if you want to know the probability from 0 and L, you integrate from 0 and L. If you want to know from 0 and x value, 0 and x. If you want to find from let's say from x value to x plus dx, so right, so it's x plus dx, right? So this is the range that you are interested in, any x values. So it's a product of psi x and psi x star or conjugate. So this conjugate, the rule is if the wave function has an imaginary number, the conjugate will be the same description of the same form of the wave function times negative of the imaginary function. Okay, so this will mean that x plus dx, you have a e I kx times a e minus I kx dx, right? So if your wave function contains an imaginary number, right, you have to multiply by its conjugate, right? So if it doesn't contain an imaginary number, just multiply it by the wave function again. So it's wave function squared. So the wave function conjugate of this wave function is the same, right? It's the same except that the power where you have the I here has minus I, right? Okay. So this belongs here and this belongs here, right? Okay, so then the product of this multiplication would be a squared, a constant, and the product of the exponents would be e to the power of 0 dx, x plus dx. And this is, if you integrate this would be so it's 1 dx, right? 1, and this would be a square x plus dx and x. Okay, probability would then be a square, so x plus dx minus x. So this cancel out. So probability of finding electrons between x and dx is just simply a squared times dx, right? Okay, so this means that this is independent of the wave function, right? The only description is dx here. So if you wanted to find the probability of the electrons from 0 and L, so it would just be L, a squared times L. Okay, so this means that because it's independent of the wave function, it has equal probability everywhere, right? Equal probability everywhere. So if you integrate between 0 to half L, right? If the electron exists between 0 and L, if you integrate the probability from 0 and half L, so you will get a squared times half of L. If you integrate from 0 to L, this will give you A squared times L, right? So at any position between 0 and L, the probability of finding the electron is equally the same, right? Equally the same.